Assalamualaikum warahmatullahi wabarakatuh. This is a video presentation for group assignment microprocessor and microcontroller BEJ 30203. Our members consist of 5 students, that is Cik Nur Hasni binti Cik Razali, Musika Rawiyah binti Azidin, Nabila Atika binti Badri Syam, and also Sultan anak lelaki Sukumaran, and Vignesh Chan Tenseng. Now I will be presenting the introduction. So basically for this project, we are required to use LPC 1768 microcontroller. The microcontroller is linked to four sensors and will read the sensor data and show the digits on the LCD. We have chosen to perform heater, cooler, LED, and temperature sensors. For our project, we use the Kill Reversion software. So basically, this is we want to make. This is the LPC1768, the cooler sensor, the heater sensor, and the driver specifications is when the input is 00, meaning the cooler and heater sensors are off. If the input is both 1 and that means the cooler sensor and the heater sensor is on. Okay, that's for me. I'll pass to my other member.
My name is Cik Nur Hasni binti Cik Razali, matric number AE190017. The objective of this project is design a program of temperature control system in a manufacturing plant using LPC 1768 microcontroller. Second, to study the sensor units that used in temperature control. And third, to simulate the temperature control system program using Kill Microvision software.
For the problem statement of the assignment, the process of maintaining the optimal temperature of manufacturing plant is essential in most of manufacturing industry. Failure in maintaining the optimal conditions on manufacturing line can bring a serious difference to the product's quality and efficiency, besides the fact that it may cause damages that disrupt the factory production. By designing a temperature sensor, the heater and the cooler can be controlled with the aid of the microcontroller to achieve the desired temperature in the manufacturing plant. By ensuring the environmental temperature remains within optimal level, the manufacturing plant lifespan will maximize and it will work at maximum efficiency.
Hello doctor, my name is Sudarshan Sukumaran and my metric number will be DE190074. So now I'm going to explain briefly for project's methodology. In this project we use the KillU version 5 software as shown in the figure 1. The another figure shows the U version project manager and the runtime environment. Okay, this software consists of project management, runtime environment, build capabilities, source code editing, and program debugging into a single effective environment. Vision is easy to use and stands the creation of embedded system. It is also support numerous displays and enables the construction of distinct window layout anywhere on the visual surface. This software is uses for testing, verifying, and improving our application code is offered by the Vision Debugger. The debugger includes the common features including simple and complex breakpoint, watch windows, execution control, and a complete view of peripheral devices. So this is the workflow of our project. The temperature that given for us is between 60 to 70 degrees Celsius. So we have to start and then we initialize and then we start again. If no, we have to initialize again. If yes, we have to read the analog. If the temperature is lower than 60 degrees Celsius, the heater will be on and the cooler will be off. If the temperature is higher than 70 degrees Celsius, the heater will be off and the cooler will be on. Let's say if the temperature is reach the range between 60 to 70 degrees Celsius or setup failure, the heater will be off and the cooler also will be off. So we have to send reading temperature to PC and read the analog. So the process will be repeating. And the example of hardware component that we used in our project is LPC1768 microcontroller, LM35 temperature sensor, jumper wires, resistor 1 kilo ohm, breadboard, and USB type A to mini B cable. That's all from me. Thank you.
Good day to doctor. My name is Vignesh. I'm at number DE190003 and I'm from group 8. Today I'm going to show a small demo video on our project. In the instruction, we are told to create a temperature control system using LPC176A microcontroller with the temperature sensor LM35, and we are given the range of the water between 60 degrees Celsius to 70 degrees Celsius. And now let's look on into our coding that we have created in QU version. This is the coding that we create. As we know, when the temperature below 60, the heater will turn on and the cooler will turn off. When the temperature is above 70, the cooler will turn on and the heater will turn off. Now, let's look into the output that we get from this coding. So we're going to build it. Make sure there is no any error or warning when we build it. Next, we're going to debug. Click OK. And now I'm going to turn on the logic analyzer. In the logic analyzer, we need to set two important things, that is our output for S2 output and also the port 2. And in the signal display, we need to set state or bit. For S2 output, I set as a state, and the port 2 I set as a bit. Now we close it. Now we're going to the peripheral. In the GIP IO, we need to turn on the port 0, and also we need to turn on port 1. Not forget about the AC ADC converter. Before we run the simulation, we need to set our 60 and 70 degrees Celsius. Okay, first let's see on 60 degrees Celsius temperature. I set 0.6 and I double click, and now I'm going to run. Here is the output for our 60 degree temperature. We can adjust it by zoom in, zoom out, or zoom all. Depends on how we want for our temperature. Now I'm going to set into 70 degrees Celsius, so I set as 0.7. I double click on port 1, and we can see the changes between 60 degrees Celsius to 70 degrees Celsius. That's all from me. Thank you.